You're about to witness the death of a star. Get ready to explore the last moments of a massive star and the incredible phenomenon that happens when it dies. Do you think you know what normal is? A comet spinning every 16 hours. That sounds boring, but when this comet comes from beyond our solar system, has crossed 4.5 light years of empty space, and reveals secrets about planets forming 13 billion years ago, boredom dies. This is 3I Atlas, the third visitor from interstellar space, and its 16-hour rotation has just broken everything we thought we understood about the deep cosmos. On the morning of July 1, 2025, Rio Hurtado, Chile, the Atlas Telescope, Asteroid Terrestrial Impact Last Alert System, captured something moving against the dense star fields of the galactic center. Not moving like our comets move. Moving wrong. Too fast, too tilted, the trajectory screamed alien. Within hours, astronomers worldwide knew they had something unprecedented. The third confirmed interstellar object ever detected passing through our solar system. But Atlas is not just a telescope. It is a global network of 4 robotic telescopes spread across Hawaii, Chile, and South Africa. Each telescope surveys nearly the entire night sky every 24 hours, hunting for near-Earth objects that could pose an impact risk. The system processes more than 100,000 images per night. On July 1st, one image contained something different. A faint point of light moving at hyperbolic velocity, faster than the sun's gravitational binding energy. The Deep Random Survey Remote Telescope in Chile, part of the Atlas network, captured the first definitive detection, but the object had been hiding in plain sight. The European Space Agency reacted within hours, immediately deploying ground telescopes in Hawaii, Chile, and Australia. NASA's Planetary Defense Coordination Office classified it as the third ever confirmed interstellar object, designated C-2025 N1 Atlas. But 3I Atlas had been hiding. Pre-discovery observations revealed it had been photographed weeks earlier. Its optical spectrum shows a red slope of about 10% per 1,000 Oro, between 0.5 and 0.8, matching D-type asteroids. But at longer wavelengths, its near-infrared spectrum flattens dramatically to just 3% per 1,000 Oro. This spectral behavior indicates large water ice grains in the coma mixed with organic compounds. The Zwicky Transient Facility captured it on June 28 and 29. More ZTF images from June 14 to 21. Atlas itself had tracked it since June 25. Amateur astronomer Sam found additional Atlas observations going back to June 4. For nearly a month, this interstellar visitor had been slipping through our instruments unnoticed. The implications astonish astronomers. Interstellar space preserves primordial chemistry across cosmic distances and millions of years. But Tony Santana Ross and colleagues published disturbing observations in August 2025. 3I Atlas grew progressively redder through July. The reddening indicates evolving surface chemistry as rising solar heating activated different components. Normal comets show similar evolution, but 3I Atlas changed faster and more dramatically than any comet ever observed. Why? It was transiting directly in front of the galactic center, where millions of background stars created perfect camouflage. The Vera C. Rubin Observatory provided crucial pre-discovery data, showing that 3I Atlas was already active. On June 21, 2025, its coma measured 13,040 kilometers across, about Earth's diameter. By July 2nd, the coma had expanded to 18,160 kilometers, a 10% growth in just 11 days. This was not normal comet behavior. Normal comets develop comae gradually as they approach the Sun. 3I Atlas was furiously venting gas at distances where most comets remain completely inactive. But the earliest pre-discovery images revealed something even more disturbing. NASA IRTF spectroscopy in July detected strong water ice absorption features from 0.77 to 0.5. but the ice signatures showed unusual thermal properties, suggesting subsurface reservoirs rather than surface frost. Water ice seems to sublimate from several meters deep, venting through fractures controlled by the 16-hour rotation cycle. Normal comets develop comae as solar heating vaporizes surface ices. Expelled material usually moves much faster than surface rotation, but 3I Atlas defies that model. The ZTF captured 3I Atlas on May 22, 2025, 6 weeks before the official discovery. Its coma spans 26,400 to 24,700 kilometers per GTC high-resolution imaging, twice Earth's diameter, yet its outflow speeds seem suspiciously low. ESO's Very Large Telescope provided key spectroscopy with the MUSE instrument in July 2025. Even then, the object showed a faint but unmistakable coma about 6,000 tolar kilometers wide. At that time, 3I Atlas was 7.1 AU from the Sun, farther than Jupiter. Most comets remain entirely inactive at such distances. Yet C2025 N1 Atlas was already active. The Instituto de Astrofísica de Canarias confirmed cometary activity using the 2M Twin Telescope at Teide Observatory on July 1st. Multiple telescopes showed the coma had a distinctly reddish color, indicating dust composition similar to 2I Borisov. But 3I Atlas showed something unprecedented. The reddish color intensified through July 2025, according to a study by Tony Santana Ross and colleagues published in August. Normal comets show gradual color evolution. Normal comets show gradual color evolution. 3I Atlas changed dramatically in just weeks, but NASA's Parker Solar Probe offers the most thrilling encounter. Its December 2025 trajectory will pass through 3I Atlas's plasma tail at 0.8 AU from the Sun. Parker's in situ instruments will directly sample interstellar material, measuring magnetic fields, plasma composition, and dust properties impossible with remote observations. If you value the documented history of space exploration like this, subscribe. It's the best way to support our work. Also, comment what city you're watching this from. This script is researched and factual using sources from the journal Astronomy and Astrophysics, August 5, 2025. Also, comment what city you're watching this from. This script is researched and factual using sources from the journal Astronomy and Astrophysics, August 5, 2025. Research notes by Harvard professor Avi Loeb on Medium, August-September 2025, including his analysis of extreme negative polarization properties that defy all known comet models and his August detection of an anti-solar tail formation. Sources also include preprint archivar 25 ADU7, T.